interest formula that we've been working with, and it doesn't earn all that much, just like one chunk of money, right? So that example that we had just done, 51 I think it was, with the wedding couple with the $20,000 that they put in, which, let me tell you, nobody gave me $20,000 for my wedding, but you know, but they had $20,000 and then they put it in a bank account and then they didn't touch it for 15 years and it doubled. But very few people in the world, in reality, have a chunk of money that big to put aside and it grows. Yeah, and then but then you never touch it, right? You just stick that $20,000 in the bank. You never add to it. You never take away from it. It just sits there like something old leftovers that you forgot in the back of the fridge. It starts growing, but you don't mess with it because, but that's not realistic. The more realistic way that people save is that you have a goal, like you make a budget and you can put away $50 or $100 every paycheck, right? Or $200 a month, or this is a more realistic way that people save money, is by putting away chunks at a time. And that's what this equation that we're going to go over tells you. So with our single deposit investment, that's the ones we've been doing. This is the compound interest formula. Okay, we've put one deposit in, and then we never put any more money in, and we never touch it again. So again, like, it's good math, it's useful, but it's not realistic to like everyday people and everyday occurrences. So our balance is equal to our principal times 1 plus our rate over the number of times compounded, and the number of times compounded times the years. So this is one time only deposit, never touch it. Okay. With this new formula, periodic investments. Periodic means that it occurs at regular intervals. So if you want to talk about like, so you're putting in the same amount at regular intervals. Okay, so for example, $50 a week, or $225 per month or something. Yeah, I'm just saying. Okay. Oh, example, yeah, example. So in this account, or in this formula, B is still our balance, but P is no longer our single one-time giant principal deposit. P is our periodic investment amount, or periodic deposit. So that $50 that you're going to put in every week, or that $225 that you're going to put in every month, or $10 a week, whatever. R is the annual percentage rate. N is the number of compounding per year, and this has to match the deposit not math. This has to match the deposit period. So let's say you're going to put away $100 a month, but your account compounds weekly. You have to divide that $100 into weekly amounts. Even if you're actually only putting it in monthly, the N number and the P, how many times, has to match. Otherwise, you don't get an accurate result. Okay, did that make sense? Didn't make sense. Okay. Yeah, if you're doing $100 monthly, but your N is weekly, you have to divide that $100. Instead of being $100 a month, it's $25 a week.
In this formula?
Yes. Yeah, then because otherwise, otherwise the formula would say you're doing $100 a week.
Right, and that's not accurate.
That's not accurate. You're doing $100 a month, which is $25 a week.
Right.
So the regularity of the deposits has to match the regularity of the compounding. That time period has to be the same. So if you were talking about like annual deposits, if it's an annual deposit, annual compounding. But if you're doing an annual deposit in an account that compounds every 12 months, or I'm sorry, once a month, not every 12 months. Every 12 months would be annually. So let's say your tax return. Let's say you somehow magically know that your tax return is going to be the same amount every year, and we'll just say it's $1,000. But you get that once a year, right? And you put it in your savings account. But your savings account compounds monthly. 12 months. You can't put $1,000 in the formula because that would look like you're putting away $12,000 a year because you're putting away $1,000 a month. So you'd have to take that 1,000, divide it by 12, and plug that number in. Does that make sense now? So it's not, usually the problems are set up to where the compounding and the deposit matches, but every once in a while, and in the real world, it's not that neat. Like if you're depositing money every 2 weeks for your paycheck for your savings account, but your bank account compounds daily, you need to know how to figure that out. Okay, so that's all. I just want to make sure you understood that those had to match. And then T is still the number of years.
So if you were doing something for half of the year, you would put in as
2. But if the bank account itself compounds at a different rate than that, you have to change the P. You want to make the P match the N. P is the deposit. Right. And so you want to make the frequency of the deposits match the frequency that the bank compounds at.
Right. So if if the bank interest compounded every 2 weeks, you want to make sure that your number is every 2 weeks.
Let's say,
The rate of every 2 weeks.
I'm just going to say I'm going to deposit $252 a month into an account.
Make it an easier number.
No, 252 isn't easy.
No, I'm not saying that. I'm saying, like, if you keep going by weeks, and that's a little more complicated than my
Yes, but here's why.
still the same concept.
Oh, here, I'm going to just do this. Okay, if the account compounds yearly, so N is 1, but you're putting away 252 per month, you're going to have to do 252 times 12 to equal P. Okay, because it's yearly. If the account compounds semi-annually, so that's twice a year, you'll do 252 times 6, because it'll be every 6 months. If the account compounds monthly, nope. We're putting it away monthly, so we don't have to change it.
And so that's what you would
Because
like
that's already what we're doing, so it already matches.
Okay.
If it compounds weekly,
Divide.
we have to start dividing. So we do 252 divided by 4 because there's 4 weeks in a month. If it compounds daily,
You divide that by 30.
yeah. And you would divide it by 30 because 30 is the average length of a month.
Right.
Okay, so if your compounding period is less frequent than your deposit, you end up multiplying to make it match. If your compounding period is more frequent than your deposit, you divide to make it match. Does that help? Not, no? Okay, good. Funny. Right, this is real world formula. And so it's a more complicated formula, but what you can do with this formula is you can look at your expenses and your budget, your paycheck, and you can say, well, I can afford to put away, $25 a week, or even $25 a month. If you can only afford to put away that much, then you can say, well, if I put away $25 a month, how much will I have in 5 years?
Right.
This lets you figure that out. You'll know exactly, if you continuously always put away that amount every month, you will know exactly how much money you'll have at the end of 5 years. And that helps you with financial goals and planning, and like, I could buy a new car or not. Maybe I should try to put away more money.
Right.
Or it helps with your planning, and this is this is more the way the world works
Right.
than the other problems we've been doing.
Right. So for B, say a car costs like P 8,700.
I don't know. Yeah.
Yeah. So if it costs 8,700, you would put in B for that.
Well, we're going to have, on the next section, I'm going to have this formula rearranged
Right.
so that you can figure it out the other way.
Right.
So with this direction, in this section, we're going from, I can put away this much money per month. How much will I have in 10 years? In the next section, when this formula has been rearranged so that you don't have to do it yourself, it'll be, I need $10,000 in 6 years to put a down payment on a house.
Right.
How much do I have to start putting away monthly now to get there? So you have both directions. You have, if I'm putting away this now, how much will I have later? I need this much later. How much do I have to put away now?
Right.
So you can go, and that's really, these are very useful for your goal planning, your financial goals, and like to set those goals of buying a new car in a couple years, or a house down payment, or paying for college or a wedding, or kids to go to college, or these are
Budgeting every day.
yeah, so this is what these are useful for. So we've got Rich and Laura, and they're 45, and they opened a bank account, and they want to retire at 65, and they're going to put $5,000 a year into an account that pays 4.5% interest compounded. You want me to change it, or you want to keep it annually for the first example? We'll just keep it annually for the first example, and then we'll change it.
Right.
Okay, so what is the balance when they retire? Now, they want to retire at 65, so T is going to be 20. So we have okay, so I'm putting in $5,000 a year at 4.5% interest. It's compounding annually, so N is 1. And that's 20 years minus 1. I'm going to have 0.045 divided by 1. Now, on this problem, because we have a fraction, this is the same thing as division, okay? So I'm just going to write that. Cross there. division. Oh, here? 1? That, yeah, 1 times 20. And then I don't know what there's a little something right there that shouldn't be. Okay, so the first thing that I do on these, because what I need to do is I need to get a number for the whole numerator and then a number for the denominator, and I need to divide them. It is the whole thing on the top divided by the bottom. But now the more accurate way to do this is to do this division first. Because if you round this division, it has less of an effect on the whole problem than if you round it up here. And I could show people how to do that, but if you make one mistake in the entry, so I want to show you how to do it step by step. If you want me to show you individually how to enter it, I will, but if you don't put in the parentheses in the right place, it's wrong. So it's easy to make a mistake like that. So what I do first, I do this division first, and that's going to be 0.045 in this case because it's dividing by 1. But if it doesn't divide evenly because it's not dividing by 1, and so you get some decimal, I usually put the first 4 to 6 decimal places and just I round to like 4 or 6 and keep that many, and that gets you accurate enough. Yeah. Huh? I haven't done it yet. Yeah. So I just did that division right there. Then I come up here and I start inside here, so I do the 0.045 divided by 1, which is of course 0.045. So this is second. Add 1 to that, that's third. Raise it to the power of 20, so that's fourth. Subtract 1 from it, so that's fifth. And then multiply it by 5,000, so times 5,000. And I'm going to get some number, I'm just saying this decimal keeps going, divided by that 0.045. I don't pull this out of the calculator, I just go ahead and divide. Divide by 0.045, and my balance is going to be 156,857.11. Now to find out how much interest they earned, they're putting in $5,000 a year for 20 years. Yeah. So that's $100,000 of their own money that they actually put into the bank. The balance is 156,857.11 minus their 100,000 that they actually deposited. So this is money deposited. Yeah, not bad. Now, if they had taken $100,000 and stuck it in an account and let it sit there for 20 years, it would have earned more money. But again, who can do that? I guess if you win the lottery, but most people don't have. Yeah. Okay, the 2% of the rich people in the world could do that. The rest of us have to do this where we put away little by little. So it doesn't earn as much, but it does earn more than not putting it in the bank. Okay, so we've got our formula. So let me write it down again. Now if you notice, it looks a lot like what we were already doing. It just added this and that. This part's the same. 1 plus r over n to the nt, that's the same as the compound interest formula. But we do the minus 1. It's just so we're going to do, okay, so here's the thing. We're doing $1,200 a month, but we're compounding daily. So what we have to do is we have to take this 1,200 and we have to divide it by 30 to get $40 per day. Now granted, we're not actually going to put in $40 per day, but for our calculations we need the compounding and the amount of money to match. Not the amount of money, but the frequency of the money, like how often we put the money in to match. So instead of putting in 1,200, I'm going to put 40 in here. My interest rate is 3.6, so I do 0.036. My N is 365. And I'm doing this for 10 years. Okay. 365 times 10 is 3650. That was easy. I like multiplying by 10. I like dividing by 10 too. Okay. This, when I do the division on it, I'm going to get 0.123496863. Now normally I said to do 4 to 6 decimal places, but since 4 of my decimal places were zeros, I'm going to go 4 beyond that. Just for the more decimal places you keep, the more accurate your answer is. Okay, so that's the same as this division here. So I'm going to add 1 to that. Up here I'm adding 1. And then I raise it to the power of 3650. Then I subtract 1. Then I multiply that by 40. And that answer that I get from just the numerator is going to be 17.323. 1221. And then some other stuff. But I'm not going to clear that out of my calculator. I'm just going to hit divide, and then I'm going to plug this in. So 0.123496863. Okay, so at the end of 10 years, $175,000, well, $175,729.07. I rounded. Here, when I did this, I rounded. Right? Because this I didn't round in the numerator, but I did round in the denominator, and so that changes things. Okay, for homework, do the problems in section 7. And that's not the right packet. Hold on.